So this is a quick video to run through the practice sheet, the practice for the quiz on Thursday. So I'm just using the unit circle, my knowledge of the unit circle to find I'm just evaluating all these trig functions based on my knowledge of the unit circle. So here we go. So basically when I'm doing this, I just draw a unit circle real quick. Oops, gotta have a pen first. So I draw a unit circle. In this case it says sine of 0, which means I'm pointing in this direction. And I want the y coordinate of that point. And the y coordinate of that point is 1. No, it's not. It's 0. Sorry. 0. Okay, number 2, cosine of 180. That thing is 180 degrees. We'd be pointing over this direction, so we're talking about that point right there. The x coordinate of that point would be -1. Secant of pi. So again, draw a quick unit circle. Pi is over here, so we're talking about that point. Secant, so it's really the same point we had up here. Secant is 1 over cosine, so this would be 1 over -1, which would just be -1. Sine of 2 pi over 3, we draw a circle. 2 pi over 3, let's see, that's 1 pi over 3 right there. 2 pi over 3 right there. Remember, that's 2 pi over 3 is the same thing as 4 pi over 6. So you could go 1, 2, 3, 4. But either way, you get this standing up 30, 60, 90. And sine is the vertical side, which in this case is the longer side. So that'd have to be rad 3 over 2. And it's positive rad 3 over 2 because it's going up. Secant of negative pi over 3. So again, I'm going to draw my little circle. Negative pi over 3. Negative just means I go this direction instead of that direction. So that would be right about there. That's another standing up 30, 60, 90 triangle, or a reference angle of 60 degrees. So, and secant is 1 over cosine. So cosine would be that little short side, which would be 1/2 in this case. But since I'm doing secant, it'd be 1/2 flipped over. So that'd be 1 over 1/2, or 2. Cosecant of 30 degrees. Again, we draw the picture. 30 degrees is right about there. Reference angle 30 degrees. That's a laying down 30, 60, 90. And cosecant is 1 over sine, so I'm looking for the sine value. It should be -1/2. So this is 1 over -1/2, which would be -2. Tangent 225. Oh, that's right down the middle because that's a multiple of 45. So sine and cosine are the same there. They're both negative here, so this would just be 1. Cotangent of -5 pi over 6. So -5 pi over 6 would be right about there, because I do 1, 2, 3, 4, 5 pi over 6. And that's a reference angle of 30 degrees. So I'm looking at the 30, 60, 90 triangle. It looks like this. 30, 60. And we know that's 1/2, and that's rad 3 over 2, and that's 1. Okay, so cotangent is cosine over sine, so that would be, in this case, negative rad 3 over 2 divided by -1/2, which would just be positive rad 3. Cosecant of -5 pi over 6. So that would be -5 pi over 6. We already did that once. That's over here, right? So just like this one over here. And we already said that sine was -1/2 because it's that little short piece going downwards there. So since it's cosecant, that'd be 1 over -1/2, which would just be -2. Right? Cotangent of 2 pi over 3. Well, 2 pi over 3 is, we found that one earlier before. That's like 4 pi over 6, so that's 1, 2, 3, 4 pi over 6. Has a reference angle of 60 degrees. So it's that same triangle, but now 60 degrees is sitting right here. So the long side is the sine. So that would be, and sine's on the bottom of cotangent, so that'd be rad 3 over 2. And the short side is -1/2, so that'd be -1/2. And of course, if we simplify that, we flip the bottom over and multiply, and we get -1 over rad 3. Cotangent of negative 7 pi over 4. That would be 1, 2, 3, 4, 5, 6, 7. Or we might have noticed that negative 7 pi over 4 is coterminal with pi over 4. So we could have just went right there. And cotangent, of course, is cosine over sine. And we know at pi over 4s, sine and cosine are the same, so this would just be 1. Sine of 120 degrees, negative 120 degrees, so that would be going backwards right about there. That's a reference angle of 60 degrees. So that's a standing up 30, 60, 90 triangle. And we're looking for the tall side, so that would be negative rad 3 over 2. Okay. So you can, I think I'll do a couple more, but I did want to point out that the answers are down here, so you could do this, but I just wanted to talk through some of these. And maybe I'll do a couple more, a little bit slower. So cosine of negative 240. So the first thing you do, draw your circle, 240 degrees, negative, so I'm going in this direction. And I know that's 180 degrees. So 240 would be 60 more. So that gives me a 60 degree reference angle. So I'm looking at a 30, 60, 90 triangle that's sitting up on its haunches, so to speak, because that's 60 degrees, right? We know the short side is 1/2, tall side is rad 3 over 2. So now in this case, though, and I'm in the third quadrant. So cosine is always the x-coordinate, so that would be the 1/2. But since I'm in the second quadrant, I'm going to the left, so this would have to be negative 1/2. There's another cosine. Let's do this cosine 390. Well, 390 is bigger than 360 because we come around here to 360. Then to get to 390, I got to go 30 more. So that's going to be a triangle with a reference angle of 30 degrees. So again, we got the 30, 60, 90 triangle. This time it's laying down. In other words, the short side is vertical and the long side is horizontal. I'm looking for the horizontal, so that'd be the long side. So this would be rad 3 over 2. Okay, I think I'll stop for now. If you're watching through this and if you're hearing me talk about this and your head's spinning because I'm going so fast and whipping around the circle, that means you've missed something in the videos from last week, that the way I'm whipping around the circle and find out where I'm at. And then also the wrapping function is how I'm coming up with these rad 3 over 2s and 1/2 and all that kind of stuff. So you might want to re-watch that video, because for the quiz tomorrow, you're going to have to be able to go about as fast as I was going. So maybe not quite that fast, but I did more of those. I did more than 10 in 10 minutes, but still, that's the idea. All right.